numbers, letter of alphabet, lines, etc. These are the formula of sets. Types of relationship in sets. Equal sets. They have exactly the same elements. Equivalent sets. They have equal number of elements. Overlapping sets. They have at least one element in common. Disjoint sets. They do not have any element in common. Thank you.
This what happened, Abbas?
Sir, finished.
Yeah, that's it.
Yes, sir.
Okay, then. Okay, that was a nice presentation. So types of sets you have explained. Okay, then you can leave. Okay, that's it for you.
Okay, sir.
Abhishant.
Bye, sir.
Okay.
Yes, sir.
Abbas, one. Just a
E-
minute. Wait.
Event, sir.
It's okay. Abhishant.
Can I
Yeah.
say, sir?
Good evening. How are you?
Good evening, sir. How are you, sir? I'm
Yeah,
fine.
you can start.
Yes, sir. Is my audio clear?
Yeah, I'm also.
Sir, is my audio clear?
Yeah, yeah.
Okay, I'll start, sir.
It's clear.
It is. It takes time to become slideshow. Wait.
Yeah, yeah. It's clear. Yeah.
It takes time for the slideshow to open, sir.
It's fine. You can see that. So your it is in profit and loss.
Yes, sir.
That, yeah. Okay, fine. You can begin. I guess.
It's like it loads. It takes time.
Eh,
Like yesterday, नहीं बात है.
eh, eh. Is
Once,
it your device slow?
yes, sir. So once can I like
So
stop, sir? And yeah, with the बिना slideshow गर्छ यतिकै.
हुन्छ. I will see the slides in Google Classroom. You have sent no? म हेर्छु यताबाट कम्प्युटरमा. Abhishant, what happened? You there? के छ हेरौँ न ल. I think it's interesting. First page खतरा लाग्यो मलाई. 5
Good
marks
afternoon, sir.
बढिसक्यो. Good afternoon.
Good afternoon, sir. My name is Krishna Shrestha, and today I'm here with the short topic, a short presentation, arithmetic.
Mm-hmm.
So let me start over the introduction. Arithmetic is a branch of mathematics dealing with the properties and manipulation of number. Arithmetic is an elementary part of a number theory, and the number theory is considered to be one of the top level division of modern mathematics, along with algebra, geometry, and analysis. So, facts and
Yeah.
history of arithmetic are: arithmetic developed slowly over the course of human history, primarily evolving from the operation of counting. Prior to 4000 BC, few civilizations were even able to count up to 10. Over time, however, people learned to associate objects with numbers. They also learned to think about numbers as abstract ideas. By far, the most mathematically advanced of this ancient civilization were the Egyptians, Indians, and Chinese. Each of these civilizations possessed whole number, fraction, and basic rules of arithmetic. They used arithmetic to solve specific problems in areas such as trade and commerce. Arithmetic developed in remote antiquity as a result of practical necessity of counting, and of the simplest measurements. It developed as the complication arose in economic activity and social relation, monetary calculation, problems of distance, time, and area, measurement, and the demands of other science. So there are only four branches of arithmetic: addition, subtraction, multiplication, and division. Addition. Addition is a term used to describe adding two or more numbers together. Subtraction. Subtraction is an arithmetic operation that represents the operation of removing objects from the collection. Subtraction is signified by the minus sign. Multiplication. Multiplication is one of the four basic operations of arithmetic. Gives the result of combining group of equal sides. Division. Division is breaking a number up into an equal number of parts. Thank you and have a great day.
Okay, that was very nice arithmetic. So I want to ask you the question. Okay, so what is after making this presentation? What is the importance of arithmetic in our daily life? What you have known? So what are the areas that we
Like,
use
so we use it in like every sector, like counting, like
counting? Yeah.
we
So if I
sector.
if, so like in if you so in future if you are doing a kind of like business and if you are involved in a trade, so what do you think in that time does arithmetic will help you or not?
Yes, sir. For the record of the those like products or money and everything.
Yes, addition, subtraction, multiplication, and division
Salary.
definitely will be used in that area, right?
Yes, sir.
Yeah. Okay, then thank you so much. You can leave the meeting and have.
Thank you, sir.
Okay, Krishala, have a nice time. Goodbye. Stay safe. Your topic is congruent triangles.
Good afternoon, everyone. My name is Raisha Shrestha, and today I am here to present a presentation on congruent triangles. So these are the contents. First of all, we have introduction of congruent triangles, conditions of congruency of triangles, and I have described all of the conditions of the congruency of triangles briefly in here. So first of all, there are the introduction of congruent triangles. When two triangles they are congruent, they will have exactly the same three sides and exactly the same three angles. The equal sides and angles may not be in the same position, but they are there. The congruent triangles, they're always similar and they have equal area. Secondly, we have conditions of congruence triangles. Two triangles can be congruent if three parts of one triangle are equal to three corresponding parts of another triangle as per the following conditions. We use these conditions as axioms, and there are five conditions as axioms. First of all, we have the SSS axiom, which stands for side, 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 and means that we have two triangles with all three sides equal, as we can see in the picture right here. This is the example for SSS axiom. Second of all, we have SAS axiom, which stands for side angle side and means that we have two triangles where we know two sides and the included angle they are equal. And this is the example that I've kept for SAS axiom. Thirdly, we have ASA axiom, which stands for angle side angle and means that we have two triangles where we know two angles and the included side are equal. And there's AAS axiom, which stands for angle, angled side, and means that we have two triangles where we know two angles and the non-included side are equal. And lastly, we have the RHS axiom, which stands for right angle hypotenuse side and means that we have two triangles where we know that the hypotenuse and one of the remaining sides are respectively equal. And by saying that, I would like to end my presentation here. Thank you and have a great day. Hope you like my presentation.
Okay, that was really interesting presentation. So, Raisha, the one question for you. So, what is the difference do you find after doing this research? What is the difference did you find between congruency and similarity?
So in like congruence, so can I say about like science? Because
Yeah, you can give your own example. You have freedom. You have
so like
however you have. Hmm.
the science math we have like two lines down there and we have like the S wala
Hmm.
up of the two
Natural.
signs, and then in similarity we have only the S. Only in
Okay.
congruence like
So
scared all the
uh, like you have defined in your definition, you have similar shape and size भनेको छ नि हैन सिमिलर
yes
सिमिल्यारिटीमा चाहिँ सिमिलर सेप मात्रै हुन्छ द्याट इज द डिफरेन्स हो कि एक्चुली सेप चाहिँ सिमिलर हुन्छ साइज चाहिँ डिफ्रेन्ट हुनसक्छ भन्ने कुरा मात्र हो सिमिल्यारिटी भनेको चाहिँ सो द्याट इज द डिफरेन्स हो कि आई होप यु क्यान अन्डरस्ट्यान्ड मोर क्लियरली इन grade 10 because grade 10 also had some related topic and that was very nice, quite impressive presentation. I like that. Okay, so thank you, Raisha.
thank you sir. So can I leave now?
Yeah, you can leave. Riza. Okay, next one is Rizansa. Okay, Rizansa, you can present.
Yes, sir.
There's no one right now. Your topic is equation, inequality, and graph.
Good afternoon, everyone. I'm Rijansa Thapa, and today I'm here to present a presentation in the topic Equation, Inequality, and Graph. The contents of my presentation are equation, types of equation, inequality, rules of inequality, and graph. Equation. An equation is a mathematical expression that contains an equal symbol. An equation defines a mathematical sentence that states that two algebraic expressions must be equal in nature. It is useful as it provides us a precise way to solve mathematical questions and makes it less complicated. Types of equation. Some of the list of math equation are involved in algebra are linear equation, quadratic equation, radical equation, exponential equation, and rational equation. Linear equation. A linear equation is an equation for a straight line. It is an algebraic equation where each term has an exponent 1. This picture on the side shows the standard form of linear equation. Quadratic equation. The word quadratic is derived from the word quad, which means square. In other words, a quadratic equation is an equation of degree 2. Quadratic equations are divided into two types. They are pure quadratic equation and affected quadratic equation. The ways to solve quadratic equation are also divided into three different parts. They are factorization, completing square method, and by using formula. This method here shows the standard form of quadratic equation. Inequality. It is the mathematical expression in which both sides are not equal are called inequality. In inequality, unlike in equations, we compare two values. The equal to sign in between is replaced by less than, greater than, or not equal to sign. It is used most often to compare two numbers on the number line by their size. This picture here shows the signs of inequality that is used in inequality. Rules of inequality. The concept of inequality has various rules like while adding a number to or subtracting a number from both sides of an inequality, the inequality signs remain unchanged. While multiplying or dividing both sides of an inequality by positive number, the inequality sign remain unchanged. While multiplying or dividing both sides of an inequality by a negative number, the inequality sign is reversed. While taking reciprocal of the terms of both sides of an inequality, the inequality sign is reversed. Graph. In math, a graph can be defined as a pictorial representation or a diagram that represents data or values in an organized manner. The purpose of graph is to present data that are too numerous or complicated to be described adequately in the text and in less space. This picture on the left is the example of the graph of linear equation, and the picture on the right is the example of inequality. Thank you.
Okay, my question to you, Vijanta. So, what is the difference did you find in a linear equation and quadratic equation? What is your observation?
So
You
in
can say in your own words, okay?
yes, sir. So
Yeah.
in linear equation, like we can find that there are two different variables. While in like quadratic
Mhm.
equation, the x is the only variable that is that is mostly used, and then also the linear equation has exponent one, whereas the quadratic equation has degree two.
Okay, that's actually the truth. Okay, your presentation was very nice. I like that. The way that you have the hard work can be seen in your presentation. So thank you so much, Rijansa.
Yes, sir. Thank you, sir. So can I leave?
Yeah, you can do.
Thank you, sir.
Nirjala,
Yes, sir.
what happened in the middle? I
Sir,
saw
I
your.
got disconnected.
Yeah, now you can again do it. Okay, do it. You are only there right
Okay,
now.
sir. So wait, okay, like I'm doing. Hmm. Good afternoon, dear sir. Today I'm gonna present a presentation on algebra. What is algebra? Introduction. Algebra is the use of letters and symbols to represent values and their relations, especially for solving equations. Tax and multiplication and division to form a meaningful mathematical expression. For example, 3x plus 2y minus 5x minus 20, 3 plus 5 is equals to 20. Solution to find algebra. Taylor is 5 times as old as Spencer. The sum of their ages is 18. How old are Taylor and Spencer? Solution. Let x represent Spencer's age. Therefore, Taylor's age is 5x. X plus 5x is equals to 18. 6x is equals to 18. X is equals to 3. Therefore, Spencer is 3 years old and Taylor is 15 years old. Now I'm gonna give you another also example. Is an equation x plus 3 is equals to 9 and we need to solve it. Solving an equation means that we need to know the possible values of the variables that when put into the equation solution. Next, solution. Let x represent Spencer is. Therefore, Taylor is 5x. X plus 5x is equals to 18. 6x is equals to 18. X is equals to 3. Therefore, Spencer is 3 years old and Taylor is 15 years old. Formula to find algebra. A square minus b square is equals to a minus b, a plus b. A plus b square is equals to a square plus 2ab plus b square. A square plus b square is equals to a plus b whole square minus 2ab. A minus b whole square is equals to a square minus 2ab plus b square. A cube minus b cube is equals to a minus b a square plus ab plus b square. A cube plus b cube is equals to a plus b a square minus ab plus b square. History of algebra. Algebra can essentially be considered as doing computation similar to those of arithmetic, but with non-numerical mathematical objects. However, until the 19th century, algebra consisted essentially of the theory of equations. For example, the fundamental theorem of algebra belongs to the theory of equations and is not nowadays considered as belonging to algebra. In fact, every real numbers, which is not an algebraic property. Now let us get to know that why is algebra important? Algebra is important because it teaches us to follow a logical path to solve a problem. It allows us to have a better understanding of how numbers move us beyond basic math and prepare us for statistics and calculus. It is useful around the house and in analyzing information in the news. Sorry,
Okay,
Dawn.
Nirjala. Okay, that was very nice, informative concept of
Yes, sir.
algebra you have presented. So I want to ask you a question.
Okay,
Like,
sir.
do you did algebra will help in other streams of math also? I mean, like, can we use algebra in arithmetic and geometry also? If yes, then how can we? Can you give any example?
I don't think like we can use in geometric or
Okay, like in geometry, no, sometimes we used to find the unknown angles. Do you know that? Like one angle is missing, and we do that. Suppose very simple example I like to give. Like there is one angle missing in a triangle, and two angles are given, like 30 and 60. Then we have to find the third angle, and we write x plus 60 plus 30 equals to 180 degree. Don't you think that is algebra?
yes, sir. That is algebra. Sir,
Yeah. So
sir, and can you again repeat the question? Like,
how can is there any link of algebra in other streams of maths, other branches of maths? Like it can be geometry also, it can be arithmetic also, and it can be trigonometry also. And that's why just one example I gave, in geometry we can use algebra, right? So algebra is basically, I just want to inform you, okay, algebra is actually basically the thing that helps us to solve the problems in arithmetic also, geometry also. So and even in trigonometry also. So basically what we can say is algebra is the backbone for all the mathematics. Okay, so that is the,
yes,
so
sir.
okay, the your presentation was very quite impressive. I like that presentation. Okay, thank you so much, Nirjala.
Thank you, sir. Bye, sir.
Bye bye. Okay, so Sadiksha, next one.
Yes, sir.
Good afternoon.
Good afternoon, sir.
Good, af- Good afternoon. So your topic is stats. Okay, you can start.
Yes, sir. Good afternoon, everyone. My name is Adiksha Pradhan, and today I'm here to give a short presentation on statistics. Contents: Introduction, stages or steps in statistical investigation, history, types of statistical method or statistics, importance of statistics, who uses statistics, reference. The first, introduction. What is statistics? The process of studying and manipulating data, including the ways to gather, review, analyze, and draw conclusions is statistics. In statistics, facts and information are collected. The word statistics is derived from the word state because it was the job of the state to keep records and make decisions based on census results. Stages or steps in statistical investigation. The statistical investigation involves the following steps. The process of identifying the problem that is going to be investigated. The problem can be simple as well as complicated. Collecting all the data that can be used for making a decision and solving the problem. Data can be in different forms such as a list, graph, or a table. After studying the data, conclusions should be drawn on the analysis of data and making decisions. History. The founder of mathematical statistics is Carl Pearson. In 18th century, statistics was used by the systematic collection of geographical and economic data by states. In the early of 19th century, collection intensified and the meaning of statistics included the discipline concerned with the collection, summary, and analysis of data. Types of statistical method or statistics. There are two types of statistical method, descriptive statistics and inferential statistics. Descriptive statistics. Descriptive statistics mostly concentrates on central tendency, variability, and distribution of sample. Inferential statistics. Those two which is used to draw conclusion about the characteristics of a population from the characteristics of a sample and check if it is reliable of the conclusion is called inferential statistics. Importance of statistics. The following points are the importance of statistics. It helps you to know proper method of collecting data using correct analysis and presenting them. It is an important process in science to make discoveries, decisions based on data and make prediction. It helps us to understand world through numbers. Earthquake, weather, volcanic eruption are also calculated with the help of statistics method. We use statistics in mathematical problems. Who uses statistics? Statistics are used almost everywhere. Whenever a data is collected and analyzed, statistics are being used. Statistics can be used from government agencies to academic research to analyze investments. These are the references I used to make this presentation. Thank you.
Okay, my question to you, Radhika. So how our country is using statistics as a important tool to provide the information? Do you have any idea on that? Not our country. You can give any example. How can it be used?
Our country or other country are using help of statistics to make populations, like we can make like in one area how much population there are with the help of statistics.
Okay, okay, Sadika. Your that presentation was actually informative. I also got so many ideas, new thing about the statistics, and thank you so much for that. Even I got the information. Your presentation was very nice. Okay, so you can leave the room. Thank you so much, Sadika.
Thank you, Supervisor.
Okay, Nishchal, are you there?
Yes, sir, I'm there.
Yeah, can you present your presentation? You are already actually late. I think maybe.
Oh, sorry, sir. Okay, sir. Wait,
It's okay. You can just start presenting. Okay. I just want to see the slides and explain that. Yeah, Nishchal.
Sir, can you hear me?
Yeah, I can hear you very clear.
Good morning, everyone.
Okay.
My name is Mr. Gurung, and today I'm here to present a short presentation on topic household arithmetic. These are my content to my presentations. Introduction of household arithmetic, electricity bill, rules of electricity bill, telephone bill, water bill, calculation of taxi fare in a taximeter, use of household arithmetic in daily life. Introduction of household arithmetic. Household arithmetic in a broad sense may deal with the regular financial activities of a household. In this chapter, among these activities, we all discuss the expenses of a household for utilizing some facilities such as electricity, telephone, etc. Besides, we will discuss about taxi fare or off-meter taxi. Electricity bill. The consumption of electricity by a household is measured in the number of units. Digital meter and dial meter are the two types of electric meters which are used to find the number of units of electricity consumed. Rules of electricity bill. These are the rules of electricity bills. Telephone bill. Telephone bill is a statement of charge charges for telephone services. Rules of payment of the telephone bills implemented by Nepal Telecom are minimum charge of 175 calls is Rs 200. Rate of charge above 175 call is Rs 1 per call. Water bill. This is a the Nepal Water Supply Corporation has implemented the following rules. As you can see, I've posted a photo.
Yes, yes.
Calculation of taxi fare in a taximeter. Following are the rates of fare in taximeter implemented by NBSM department. House of how uses of household arithmetic in daily life. Household arithmetic helps us to understand telephone bill, water bill, taxi fare, electricity bill. Thank you. So answer.
Okay, Nistal. So why do you think, my question to you, okay, very simple. Why do you think this arithmetic is called household arithmetic?
Because like, so can you repeat the question? So can you repeat the question?
Just a minute, okay, Nistal. My question is, why this arithmetic? Why this subject is arithmetic? Yeah, it's a part of arithmetic, but why it is called household arithmetic? Why we are calling separately the arithmetic as household arithmetic? My question is that.
So I guess like because like it's useful in like household things, no, like electricity bill and
Yeah,
then like
that is
telecom bill.
actually the 100% correct answer. I just wanted to know that how much are you aware about it. So have you ever used this kind of thing in your life? I mean, like
Mm,
calculation of electricity bill in your home.
no, sir, I haven't.
It's okay if you haven't used, but I like to tell you. Okay, so nowadays that taxi fare is not much use, but it was earlier. It used to be used because nowadays so many new system has been made. So definitely, that is just for the information. Okay.
Yes, sir.
Now that, because you know that now this vehicle system have been changed, this new kind of thing has come, like that Pathao,
Yes,
Tutal
sir.
and everything. No, so basically that won't be in the use, but you need to have the knowledge and ideas.
Yes, sir.
Okay, that is only the thing. Okay, that was my information to you. Okay, thank you so much, Nistal. It was very nice. Your presentation, the style I like. It was quite impressive. Thank you so much, Nistal.
Thank you, sir.
Okay, next one is Pransu. Okay, because Pransu also is late. Pransu.
Yes, sir.
So it's your turn. So what is your topic, and you can start presenting.
Good afternoon. My name is Pranta and I am here to present a short presentation on algebra and indices. Content: algebra, indices, laws of indices, use of algebra in daily life, use of indices in daily life. Algebra: the part of mathematics in which letters and other general symbols are used to represent numbers and quantities in formula and equations are called algebra. Indices: an index or power is the small floating number that appears after a number or letter. Indices show how many times a number or letter has been multiplied by itself. Laws of indices: there are certain rules which are applied in the operation of indices of algebraic terms. These rules are known as laws of indices. Use of algebra in daily life. You can use algebra to an all-purpose tool or a magic wand that can help deal with everyday problems of life. Algebra can help you to measure your living dimensions and determine the size of an electric item like TV or refrigerator that will fit comfortably in the space. Use of indices in daily life. Indices are used in computer games, physics, pH, and Richter scale measuring scales, science engineering, economics, accounting, finance, and many other disciplines. Exponential growth is a critically important aspect of finance, demographics, biology, economics, resources, electronics, and many other areas. Thank you.
Okay, that was also very informative. You have given some new ideas of algebra to me also. So my question to you will be like, do you find any link between algebra and arithmetic, and even with the other branches of math like geometry, trigonometry, statistics? Do you find the link or not? How algebra help you in other branches of math? If yes, then what is it?
Yes, because we need to measure, in every.
Okay, that's a nice answer. Okay, Pransu, that was also good in presentation. So thank you so much. All the best for your tomorrow's presentation also.
Thank you, sir.
Okay, thank you, Pransu. Safal, your turn.
So not being slideshow on this or what?
Okay, doesn't matter. You can click only. Abhishant was also having same problem. You just click the thing. I will understand. Okay, fine, fine.
Will become.
You can.
Afternoon, my name is Safal Sewal and I'm here to present a short presentation on similar triangles. Introduction. If two angles of a triangle have measures equal to the measures of two angles of another triangle, then the triangles are similar. Corresponding sides of similar polygons are in proportion and corresponding angles of similar polygons have the same measure. History of similar triangles. Thales of Miletus is the great mathematician who found the similar triangles. In geometry, the two figures are said to be similar if they have one and the same shape, though not necessarily the same size. The symbol we use to indicate similarity is due to the German mathematician Gottfried Wilhelm Leibniz. Similarity theorems. Similar triangles are easy to identify because you can apply three theorems specific to triangles. SAS, side angle side, ASA, angle side angle, SSS, side side side, RHS, right angle hypotenuse side. The application of similar triangles in real life. Similar triangles can be used to measure the heights of very tall objects such as trees, buildings, and mobile phone towers. Similar triangles play an important role to represent the doors in a structure design and how far they swing open. It is used to analyze the stability of the bridge, useful in measurement of room and scale size in construction. Information gathered from. Thank you.
Okay, Safal. Your topic was similarity. So, do you know the concept of congruency also?
Uh,
Little bit, right? So, if you
yes,
know,
sir.
then yeah, then what is the difference in congruent triangles and similar triangles? Can you elaborate in your own words, whatever you have observed? Okay.
Uh, so like congruent means like being exactly the same, no?
Mm, yeah,
And
same
like
shape and size also same,
yeah,
but in
and same
similarity uh, that doesn't happen. No,
figures have the same
only the
shape.
shape is similar, but sides may not be similar, right?
Yes, sir.
Okay, that you are quite informative on that. I like that. Your presentation was also informative. Thank you so much, Sapar.
Sir.
You can leave the room. Okay. Hello. Good afternoon, Sahaj. Good afternoon, Sahaj. So I think
Geometry is one of the oldest branches of mathematics. It is concerned with properties of space that are related with distance, shape, size, and relative position of figures. The types of geometry are as follows: geometry triangle, geometry similarity, geometry parallelogram, geometry circle, geometry construction.
okay.
Types of angle: accurate angle, which is less than 90 degree; right angle, which is neither less or nor greater than 90 degree, which should be always exactly 90 degree; observed angle, which is greater than 90 degree but also less than 180 degree; straight angle, which is exactly 180 degree; reflect angle, greater than 180 degree; full rotation angle, exactly 360 degree. Point. The most basic concept of geometry is the idea of a point in a space. A point has no length, no width, and no height, but it does have location. We represent a point by dot and we label point with capital letters. As you can see in the picture, A point and B point. Straight line. A straight line is a set of points extending indefinitely in two directions. A line has no width or height, but it does have length. Of course, a straight line is the shortest locus passing through any two fixed points. We can name a line by any two of its points, A, B, and straight line. Line segment. A line segment is a piece of a straight line with end points. It has a fixed length. A line segment may be horizontal, vertical, or oblique. As you can see in the picture, A and B are horizontal, and C and D are vertical, and E and F are oblique. Parallel line segment. Two or more line segments are said to be parallel if the perpendicular distance between them any point is the same. The symbol slash slash is used to indicate is parallel to. Angle. The meeting point of two line segment is called an angle. The symbol angle is used to denote angle in ABC. B is called its vertex, and AB and BC are its arm. Perpendicular segments. Two line segments are said to be perpendicular to each other if they form right angle when they intersect. The symbol is used to denote is perpendicular to. Similar triangles. Although the adjoining triangles are not equal in size, they have the same shape. Because of their similar shape, they are similar triangles. Geometrically, two or more triangles are said to be similar under the following conditions. Thank you. I hope you liked my presentation.
Definitely, I like the presentation. You have tried to cover so many things just few slides. The whole geometry, it was a kind of revision to me. So I want to ask you one question. So can you just tell me what is the condition to be a parallel, two lines to be a parallel? What have you understood during your thing? Yeah, there you have written two or more line. That is two, I guess.
Yes,
do you
sir.
do you do you can you
Sir,
tell any? Yeah,
sir, I found this.
yeah. What you found? Okay, it's okay, Saksham. You can just
Sir,
end
I
your.
mistakenly muted and said,
Uh,
"Hey, sir, this I found this parallel line in that. Okay, the review,
uh,
no, the review of geometry only. Hey,
mm,
this parallel
uh,
line are that kini. We
uh,
can use some of the formulas. Okay, like you taught us in class, no, that we can use some of the
mm,
different types of angles.
interior है ना?
Yeah, yeah, those only. If there are
Yeah.
parallel, no, we can use some of those that for co-interiors, those kind of formulas. Like as you can see in this
Okay,
right
fine, fine.
section,
I
no,
got it.
we can't use this. Okay.
Uh, okay, fine. I got it. It was nice presentation. You have done lots of hard work in it. I can see that. Uh, and that was very informative also. So
Thank you.
thank you so much.
Thank you, sir. Sir,
Okay, thank you. You can leave the room. Okay.
okay,
Yeah.
sir. Sir,
Yes.
I have one question only. Sir,
Yes.
we need to submit this in that presentation time allocate or this another one, topic one.
Topic one. You have
Okay,
to put it on topic one. Okay.
okay, sir.
That is allotted is just the timing only, just for informatic only. Okay, Simran. The next one is Simran. How are you, Simran? Good afternoon.
Good afternoon, sir. I'm fine. How are you?
Yeah, I'm also fine. Hope you are staying safe in the home.
Yes, sir.
So, what is your topic?
Sir,
What
trigonometry.
have been? I don't. Oh, that is a quite interesting topic. Yeah, you can start. Eh?
Sir, it's the screen.
Mm-hmm. Yeah, little bit. Your voice is not coming clear.
Sir, is the screen visible?
Yeah, screen is visible, but your screen is visible.
Good afternoon, everyone. It's me, Shimran Shrestha, and today's main objective is to let you all know about trigonometry. Introduction. Trigonometry is a branch of mathematics that studies relationships between side lengths and angle of triangles. In the figure alongside is a right angle triangle where angle B is a right angle. The longest side, which is the opposite side of right angle, is the hypotenuse, and there are other two sides, the opposite and the adjacent. The naming of the sides depends upon which angle is involved. The opposite is the side opposite the angle involved, and it is called the perpendicular. And the adjacent is the side next to the angle involved, but not the hypotenuse, and it is called the base. This is the Pythagoras theorem, and as you can see in the picture here, A and B represents perpendicular and base, and C represents hypotenuse. Trigonometric ratios. The ratios of any two sides of a right angle triangle with respect to one of the two acute angles are known as the trigonometric ratios. The three main trigonometric ratios are sine, cos, and tan. These are the formulas of the two trigonometric ratios.
Values of trigonometric ratios of some standard angles. The angles like 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree are commonly known as standard angles. The values of trigonometric ratios of the standard angles are shown in the following table. These values of trigonometric ratios can also be obtained geometrically without using the table or calculator. Application of trigonometry. There are various direct applications of trigonometry in activities of our daily lives. We are actually also surrounded by many applications of trigonometry, but we are all unaware about them. For example, certain concepts and measurements in the construction of houses and cars are based on trigonometry. Technology used in medical imaging, computer graphics, etc. are also developed and manufactured using trigonometry. Some real-life examples of the applications are as follows. The pyramids of Giza. Primitive forms of trigonometry were used in the construction of these wonders of the world. Jantar Mantar Observatory. Trigonometry has played a major role in calculating distances between stellar objects and their paths. Grand Canyon Skywalk. Geologists had to measure the amount of pressure that surrounding rocks could withstand before constructing the skywalk with trigonometry. Thank you. And here are some references that I took.
Okay, that was informative, Simran. I'm quite impressed with this presentation also, and even like you have mentioned the like that pyramid of Giza, and even I didn't know about that, so I also got the information. And so, can you tell me one thing? So, which field is trigonometry is basically used then, in your conclusion? Which field means like medical field, engineering field, or maybe like business field, whatever. So, where is basically the trigonometry is as a use application?
Sir, like mainly it focuses on like engineering and medical field, like for the constructions of houses, buildings, and in medical like manufacturing and all.
Okay, so your informations are so much 100% organic, and I like that. Yeah, thank you, Simran, for this nice presentation and informative. Have a nice time. Goodbye.
Thank you, sir. Bye, sir.
Okay, bye. Suniva. So you are right now. You are only there. Actually, it's the turn of season, but season is not there. So you can just do your presentation. Okay, Suniva. Hello, Suniva. Are you there?
Yes, sir. Good afternoon, sir.
Good afternoon. So you can start your presentation. Okay.
Good afternoon, respected teacher. I'm Suniva Maske, and today I'm going to present about histogram and pie chart. Content: Introduction of histogram. Example of histogram. Steps to follow to make a histogram. Introduction to pie chart. Example of pie chart. Steps to follow to make a pie chart. Sir, once wait, okay, the screen is being too much like slow. Introduction of histogram. Statistical data can be represented by various types of diagrams, such as bar graph, line graph, etc. A histogram is a graphical representation of a continuous frequency distribution. We can draw rectangular bars with class interval spaces and corresponding frequencies as heights. It was introduced by Carl Pearson. A histogram is used for a continuous data. These are some examples and pictures of histogram. Steps to follow to make a histogram. Following are the steps to follow to construct a histogram. If the given frequency distribution has inclusive classes, we should change it into continuous classes. We should choose a suitable scale and mark the classes interval on the axis and the corresponding frequencies on y-axis. We should draw a adjoining rectangle on x-axis and class interval as base and the corresponding frequencies as height. Introduction of pie chart. A circular graph in which the angle of sector represents the frequencies is known as pie chart. The earliest known pie chart is known by William Playfair in 1801 AD. He represented an illustration that a pie chart contains. Pie charts are widely used in business work. Pie charts are used to represent the collected data in the single chart. This is the picture and example of a pie chart. Steps to follow to make a pie chart. Following are the steps to follow to make a pie chart. We should add all frequency as a fraction of the total frequency. We should change each fraction into degrees by multiplying by 360 degrees. We should arrange the angle in ascending or descending order. We should draw a circle, then draw a radius as starting point. We should use a protractor to construct an angle at the center. Thank you.
Okay, that was your very nice presentation, and I want to give a review on your presentation. Like the topic was very small; it was just histogram and pie chart. But though you have tried to maintain the much more information than we could have done it, and it was very informative. So, but one question I would like to ask you: so, what is the difference do you find in the histogram and bar diagram? If you know about bar diagram, so do you know about bar diagram?
Yes, sir, kind of.
Yeah, then what is the difference have you observed if you have, because bar diagram is a thing that we have learned in our junior classes and histogram is the new thing for you, right? Still there is a difference. So but what is the difference have you found? What is your observation? You can say in your own words, no need to be like theoretical. And so can you say the difference?
Sir, like histogram are like used to show the distribution of different kind of materials and stuff, but then like the bar graph is used to compare between different grades or like things.
Okay, that is the correct answer. And structural wise also I can see the difference. Yes, bar diagram has kind of gap in the between, but histogram they are attached, isn't it?
Yes, sir.
Okay, thank you so much, Suniba. That was very nice one.
Thank you, sir. Bye, sir.
Okay. Okay, next one is Sulabh.
Yes, sir. So wait, I'll
Your
share.
turn. Okay, your presentation. You
Okay,
can start sharing your screen and can start the presentation. After Sulabh, Sujan, you be ready. Okay.
is it visible, sir?
Yeah, it's visible. Congruent triangles.
What happened? Good afternoon, everyone. My name is Sulabh Shrestha, and I am here to give a short presentation on congruent triangles. Contents: congruent triangle, conditions of congruency of triangles, types of axioms, application of congruency in real life. Congruency of triangle. Two or more triangles are said to be congruent if they have the same shape and size. In this case, when one triangle is placed over another triangle, their corresponding parts exactly coincide to each other. The congruent triangles are always similar and they have equal area. Conditions of congruency of triangles. There are 3 sides and 3 angles in a triangle. 2 triangles can become congruent if 3 parts out of 6 parts of one triangle are equal to 3 corresponding parts of another triangle as per the following conditions. We use these conditions as axioms. Types of axioms. SSS axiom. In triangle ABC, here you can see in triangle ABC and triangle PQR, AB is equals to PQ, BC is equals to QR, and CA is equals to RP. Therefore, triangle ABC is congruent to triangle PQR. In number 2, SAS axiom. In triangle ABC and triangle DEF, AB is equals to DE, angle B is equals to angle E, BC is equals to EF. Therefore, triangle ABC is congruent to triangle DEF. ASA axiom. In triangle ABC and triangle DEF, angle B is equals to angle E, BC is equals to EF, angle B is equals to angle F. Therefore, triangle ABC is congruent to triangle DEF. Number 4, RHS axiom. In triangle ABC and triangle PQR, angle B is equals to angle Q. Angle side AC is equals to PR. BC is equals to QR. Therefore, triangle ABC is congruent to triangle PQR. The last axiom is AAS axiom. In this axiom, angle B is equals to angle R, angle Q, angle C is equals to angle R, and angle BC and side BC is equals to side QR. Therefore, triangle ABC is congruent to triangle DAF. Applications of congruency in real life. In the real world, congruent triangles are used in construction when we need to reinforce structures so they are strong and stable and do not bend or buckle in strong winds or under load. Reference CMAT's book. Thank you.
Okay, that was informative about the congruent triangles, and it was very nice presentation. You have included many information of congruent triangles, but still I want to ask you the one question. What is the difference do you find in similarity and congruent triangles? Similar triangles and congruent triangles.
In similar triangles, the size may be different, but the ratio will be same. But in congruent, the size and ratio will be same.
Okay, that was very quick answer, and that was correct answer also. So I like that. So thank you so much, Sulabh.
Thank you, sir.
Okay, you can leave the room. Sujan, are you there?
Yes, sir.
Yeah, it's your turn. Okay, exactly 4:30. Sahaj part. Sujan, you can start sharing. Okay.
Good evening. My name is Suzanne, and I'm here to give a short presentation on OGIF and pie chart. The content consists of OGIF curve, less than OGIF, greater than OGIF, pie chart, and why it is used. OGIF curve. OGIF curve is a cumulative frequency curve. It is a freehand graph that shows the curve of a frequency. OGIF is best used when the total frequency is to be displayed at any given time. Less than OGIF curve. It is a rising curve. They are drawn by freehand to give less than cumulative frequency curve or less than OGIF. This is the OGIF data. This is the data which is given before we make the less than OGIF curve.
Greater than O give. Greater than O give is a graph of the greater than cumulative frequency. The frequency are accumulated from below. The uppermost point is joined with y-axis at the upper limit of the last class. Less than O give and more than O give graph. This is the graph of more than O give and less than O give. As we can see, the blue is more than O give and orange is the less than O give. Pie chart. Pie chart is a type of graph in which a circle is divided into sectors that each represent a proportion of the whole. Why is pie chart used? Pie chart is a good way to display data when we need to show how something is divided. This is the example of pie chart. Thank you.
Okay, Susan, that was very nice, informative. The talk content was very small. I gave you the very small content, but you have tried to mention so many information in this through this presentation, and I'm really impressed with that one. So do you know that you have presented one picture where two less than OGIV and more than OGIV are crossing each other? Can you go to that slide once?
Yes, sir.
Okay, no need to go actually. You just see that slide, you know. So do you know that what is that point is, sir? Okay, Aryan Busal, I can see you. Okay, just a minute. Do you know what is that point point of intersection is called? I'll give you the option if you don't know. Hello, Sujan, you there?
Yes, sir.
Yeah, what is that point of intersection is called?
I don't know, sir.
Is it median or mean? Okay, I'm giving you the option.
Oh, it's made in nothing, sir.
Yeah, that is the thing, right? So that is the thing you should not forget. Okay, less than OGIV and more than OGIV is also the process to calculate the median. So for your information, I'm telling it because in the future, future means I mean like in your senior classes, you might have to study those things. So that time you can tell it's a median. Okay, the intersection point is called median. Okay, thank you, Susan. That was very nice presentation. I just like that one. So the next one is Aryan Vushal. Aryan Vushal, you are so late. Why were you not here at 3 o'clock? You're not prepared or what? Okay, I don't want to know anything. So just you can start your presentation. Okay. Hello, Aryan. Can you hear me? I don't think so. This is Aryan. Aryan. Okay, Aryan, do you have your presentation ready or not?